Hello, I welcome you all to your own channel MSK Learning. Now we are going to discuss about the bulk modulus. So bulk modulus is what? That simply you can say it is elastic constant, and you can define that bulk modulus is the direct stress to the volumetric strain. So now we can say bulk modulus, it is the ratio of direct stress, right? Ratio of direct stress to the volumetric strain, right? So we can denote the bulk modulus by K, right? The bulk modulus is denoted by K, capital K, right? So bulk modulus, mathematically you can express that K is equal to direct stress by volumetric strain. So strain we already discussed, that is change in length by original length or change in dimension by original dimension. So direct stress means what? That whenever a body is subjected to mutually perpendicular like and equal direct stresses, right? So the ratio of direct stress to the corresponding volumetric strain is a constant, and that constant we call it as a bulk modulus, right? And when the body is subjected to the stress, it is limit condition. We will consider it as a elastic condition, means that when the load means body is unloaded, the material can regain its original shape and size. So this is your expression for bulk modulus. You can write it in this way also, that K is equal to direct stress is sigma, and the volumetric strain is nothing but the change in volume by original volume, right? That is sigma by dV by V. So this is your bulk modulus. Now we'll move to the next, that we have one topic we will see, that we are going to derive the relation between Young's modulus and the bulk modulus, right? So our topic will be that this is the expression for, you can say, expression for Young's modulus, right? Young's modulus and bulk modulus, right? And bulk modulus, right? So expression for elastic constant, that is Young's modulus and bulk modulus, right? That is simply you can say Young's modulus is E and bulk modulus is K. So now this type of expression is very important, right? From university exam point of view, or in some when you write the competitive exams for conventional paper like descriptive paper, right? So in your paper, in those places you can get such questions, that you have to express the relation between these elastic constant like Young's modulus, bulk modulus, Young's modulus, modulus of rigidity, and bulk modulus, right? That Poisson ratio is also involved in these cases, right? Now, so now for that, what we will do, we have to draw one, means we have to consider one cube, okay, of having length is L. So let us, first of all, we are drawing one cube of having length is L. So let's do that. Here you can, this is the cube I am drawing, right? So right, okay. So this cube is having length, you can say, that is L, means side, right? Length in the sense that side. Why? Because in cube all the sides are equal, right? So we can naming this cube. So you can name them like this, that let's say this is your A, B, these are the face, right? A, B, C, D is one face, right? And another face is A, E, let's say this is F, right? And another face is nothing but the, you have a E, F, G, H, right? So this is G and this is the H. So 2, 4, 6 faces is there. One A, B, C, D, right? E, F, G, H, ADEH and BCGF, or you can say BC, yes, FG, is it or not? So these 6 faces is there. So now these 6 faces are subjected to the stresses, right? So on each face you have a stress. Let's say on this stress ABEF, the stress is here, right? And another stress will be, I'll show you with this, so it will be easy, right? So this is a stresses sigma and sigma. So if you see, this is the y-axis, is it or not? And this is the x and this is the z-axis, right? So for better understanding, you can draw like this. Let's say this is z coordinate, z-axis, and this is your x-axis, and this is your y-axis, is it or not? Now, so on y-axis you have a sigma. This sigma is a stress is induced. Similarly on x also we have a, that is a stress sigma is acting, and this on x-axis the next stress will be this, right? On this side, on the x-axis, this is y-axis, and now we have the z-axis, right? So this will be one stress, that is sigma, and another stress on this, which is like this. Let's say it is the sigma, right? Now, so if you look at any face you can take, means any side you can take, either you can take AB, EF, BF, AE, DC, anyone, right? So let's say I am considering one side AB, is it or not? And then we have to see that on the face, on side AB, the stress is acting, this stress is acting, right? Now that is this one, sigma, right? And this sigma. Very carefully you will see. So when that on the side AB, this sigma and sigma will act, then what will happen? It means that on the side AEHD, right, and BFGC, that is the stress will act, the strain will be produced. That strain is tensile strain, okay. And on the another faces, like another faces means what? AEFB, right, and the HDCG, that is the strain will produce, but this strain will be compressive. Why? Because the stress you are applying the tensile stress, right? So as the long this length, that along the x-axis the length will increase, but along the y-axis and along the z-axis the length will be decreased. So when the length will decrease, it means that whatever the strain will produce, that strain will call it as a compressive strain, right? So for that, first of all you can write some nomenclature, that this one, sorry. So you can write some nomenclature, that let L is the length of the cube. L is the length of the cube, right? L is the length of the cube, right? Length of the cube. And as the length will be changes because of this stresses, so dl is the change in length of the cube. dl is the change in length of cube, right? Change in length of cube. Similarly, you have material is, that cube is made up of some material, so that material is having Young's modulus. Let's say the Young's modulus of the material of the cube is E. So E is the Young's modulus of what? Of the cube of material by which the cube is made up. So Young's modulus, okay. Then sigma is the tensile stress. We all, on all faces, if you look at, we did not apply the compressive stresses, right? So either on x-axis or on y-axis or on z-axis, we have applied the tensile, means we are pulling the body, right? So you can say sigma is the tensile stress. Sigma is the tensile stress acting on the faces, acting on faces, right? On all 6 faces we have considered, right? And that mu is the Poisson ratio. You can say mu is equal to, that is mu is Poisson ratio, right? Mu is the Poisson ratio, okay. Now then what we will do, that you have to consider the strain at one of the side of the cube. Let's say I am considering the AB. So you can mention that let us consider the strain, consider the strain of one of the side of the cube, right? One of the sides of the cube. So we can say, one of the sides of the cube, say AB, means we are considering that side is AB, right? So under the action of three mutually perpendicular stresses. So AB is under the action of three mutually perpendicular stresses. So say AB under the action of three mutually perpendicular stresses. Three mutually perpendicular stresses, right? Now, so if I show you again the figure, that cube, so this face we have taken into the consideration, right? That is, this is our face AB, right? And this face AB is means on this face AB the stresses is acting sigma, right? Tensile stress. So when the tensile stress will act on the AB, then what will happen? Along the AB, the length will increase, the cube length is increased, but along y axis it will be decreased, and along z axis also it will be decreased. It means that on x axis, that when you find out the strain on these faces, that is what, AEHD, okay, and BFGC, that strain will be the tensile strain, but the strain on this face AEBF and HDCG, right, as well as the ABCD and EFGH, the strain on these faces will be the compressive, right? Now, so now you can say that the three possibility will be here, so all possibility you can write, right? So write down fast that strain of AB due to stresses, right, on the faces, what, that you can show AE HD, right, and BFCG. Again I'll show you, this is very important, right? So I have considered this AEHD and BFGC is what, tensile. If you understood this, then the game is over, right? BFCG is tensile, and what is the magnitude of that strain? That strain is nothing but the stress by Young's modulus, and is equal to sigma by E, right? Now, then similarly you can say strain of AB due to stresses on the faces. Which face? That another two faces you can consider. Let's say the y-axis. Y-axis means what? ABFE and DCGH, right? So you can say the second case, you can consider that second case is, this is one, let's say this is one, right? So on the faces, what are those? ABEF, and the bottom face is CDGH, right? CDGH, right? Is what? Is compressive. And what is that magnitude? That is equal to minus mu times of sigma by E. You know the Poisson ratio is lateral by longitudinal. So these strain is the lateral and this is the longitudinal, right? So that's why it is Poisson's ratio times of strain on that strain on the longitudinal axis. Then third you can say, the third on the z axis you can say, on the faces, z axis is your ABCD, very good, that is ABCD, and the back of that EFGH, right? And EFGH is also compressive, right? Is compressive and equal to what? Minus mu times of sigma by E. So these three strain we got on the side AB because of the stress sigma, right? That is on longitudinal stress, one longitudinal and two lateral, right? So now you can find out the total strain in the cube, right? So total strain is what? Sum of these three strain, right? So you can say the total strain is equal to what? That sum of these strain, that is sigma by E, total strain of AB. You can, as you have considered AB, so you can write AB is equal to what? Sigma by E minus mu times of sigma by E minus mu times of sigma by E. When I get common sigma by E, so this will become sigma by E of 1 minus 2 mu. Let's say this is equation 1, right? And the strain, total strain is what? That dl by L, change in length by original length. So this is change in length by original length. Let's say this is equation 1, that strain is the total strain, total change in length by original length, right? So dl by L, this is the strain, and total strain is this one. This is equation 1. Now we have to consider the original volume of the cube is V, and volume is what? The side cube. So V is equal to L cube. So you can say here that the original volume of cube. So original volume of cube is equal to what? V is equal to L cube, right? This is the equation 2, right? Now differentiate this equation with respect to dl. So we can say differentiate the above equation with respect to L. So what is that? That you will get dV by dl is equal to 3L square, right? Or you can say dV is equal to, change in volume is what? 3L square times of dl. Let's say this is equation 3, right? Now, so again if I see that this is your dV and this is the V, so we need to find out the volumetric strain, right? So if I divide this equation 3 by 2, so what we will get? We can say dividing equation 3 by 2. So what is that? dV by V, equation V2 is this one, right? So dV by V is equal to 3L square dl by 3L square dl by L cube. So this L square and this will get cancelled. So what is that? That dV by V is equal to 3 dl by L. Is it or not? Right. So again, that dl by L is what? The dl by L we already calculated, that is total strain in a cube is sigma by E 1 minus 2 mu. So we can substitute dl by L from this, right? So you can say substitute dl by L from 1. So you can say substitute dl by L from 1. So from 1. So from 1 is what? That equation dV by V is equal to 3, right? And dl by L is what? dl by L is nothing but the sigma by E times of 1 minus 2 mu. Okay. So now again this dV by V is equal to this value we got, change in volume, that is change in volume by original volume, and this is known as the volumetric strain. Now if I know that what is the bulk modulus, so bulk modulus we already discussed at the beginning of the class, that is direct stress by volumetric strain. So now we can introduce, to simplify this equation, that bulk modulus is equal to bulk modulus, here you can write bulk modulus what? K is equal to direct stress by volumetric strain, right? So K is equal to what? Direct stress is sigma and volumetric strain is dV by V, but dV by V already calculated, which is what? This is nothing but the 3 sigma by E into 1 minus 2 mu. So we are going to substitute, so that K is become sigma by what? You can write 3 sigma by E into 1 minus 2 mu, right? So sigma sigma get cancelled. So let's cancel them. Sigma and sigma get cancelled. So what is remaining? That K is equal to, E will goes up, E by 3 into 1 minus 2 mu. This is one of the relation we got. That is, this relation is for the bulk modulus and that is the Young's modulus. Also the Poisson ratio is also involved, right? So if you simplify, you will get that. Then just change the position, that E is equal to, Young's modulus is equal to what? 3 times of K into 1 minus 2 mu. As you have to derive the relation, express the relation in Young's modulus and bulk modulus. So Young's modulus is equal to what? 3 times of bulk modulus into 1 minus 2 mu. So this is our required relation. So we in this class we discussed that we generated the relationship between Young's modulus and the bulk modulus. So in next video we are going to see some more relation between different modulus of elastic constant. So please do like, subscribe, comment and share this channel. Thank you.